My name is Ashley Cronk. I'm a second year PhD student in the Material Science and Engineering program, and I currently work with Professor Shirley Meng in a laboratory for energy storage and conversion. I'm currently working in the cobalt-free subgroup, uh, aiming to develop cobalt-free cathode materials for next generation lithium-ion batteries. That's what's so exciting about material science is there's so much room to innovate. There's so much more to change. And at the end of the day, the limitations for mechanical engineers or civil engineers and even electrical is sometimes the material themselves. So for the lithium-ion batteries that we use today, the most common transition metal element that's in our lithium-ion batteries is cobalt. And unfortunately, cobalt is expensive, and where it's sourced from is in Africa, in the Congo area specifically. And so by eliminating cobalt, we not only reduce the cost of our lithium-ion battery, but we also have this kind of conscious engineering aspect, right? We're kind of developing a material that is more sustainable in a sense. Cobalt is also extremely toxic. So by eliminating the cobalt altogether, we're kind of tackling cost, efficiency, and we have this environmental justice aspect as well. And so that's what makes me really passionate about the cobalt-free project. I definitely don't want to discount any path. I think a hybrid between research and industry and also academia is definitely what I'm looking towards. I'm also interested in getting involved into science policy. But I think at the end of the day, I think we're just trying to change the world and develop conscious technologies that benefit everybody, I think is the main mission. Yeah, so working with Professor Meng has been extremely not only challenging and rigorous, but also amazing at the same time. Working in the lab, not only getting the technical skills to perform good research and to push the boundaries of what we're trying to do, but also I think graduate school there's another aspect. There's a professional aspect. You learn to team build. You learn to communicate and work with collaborators. You learn to public speak, and I think all of those aspects are extremely important to working in not only academia but in industry. So I think it's a well-balanced recipe, right? It's not just being a great experimentalist and knowing how to do TEM or all these advanced characterization tools, but it's also being good at that and also being good at being a team player in a sense. Yeah. I mean, if you have a larger research group, you're going to have an expertise in almost every field, and being able to utilize those resources and being comfortable with asking for help when you need it is extremely valuable and has really changed, I think, or has made my graduate experience very positive thus far. Yeah, some of the great things of working in a large group is being able to utilize everyone's expertise and having the comfort or the ability to approach someone and ask for their help has really changed my outlook and my experience in a positive way in graduate school thus far. What's exciting to see, especially with this Institute of Materials Design and Discovery, is this push for collaboration and interdisciplinary work. I think that's what's really going to be what's going to push material science in the future, is being able to learn from all these other people in other fields and take their knowledge and apply it to a problem or a single mission. And so I think, incorporating things like artificial intelligence or machine learning into material science is something super exciting. And I see that kind of being a future field for sure. For me, I think material science, one of the biggest things I hope to see in the future is helping underserved and marginalized communities really kind of level the playing field. Yeah.